So this is lesson 4.1a in college trigonometry, graphs of the sine and cosine functions. And we're going to have quite a few videos here on this one section as we introduce a whole brand new part of trig. We're going to start with what is called a periodic function. Alright, if you've ever seen a sine wave before, it looks very much like this that I have right here. Let me get some of this out of the way here. This is the sine wave, and notice it goes here, up, and then down, and then up again. Alright, so that's what we're going to be doing, is we're going to be drawing sine waves. So we're going to be moving from this unit circle into making it look like a sine wave, and then later on a cosine wave. And a couple of the things that you need to understand when it comes to these periodic functions, first of all, is called a period. A period is where this sine wave starts repeating itself. So it goes all the way through here, and when it comes back here, it starts repeating itself. So that distance is called its period, and it is one period. And see how long it took it to get through that one period? It took 2 pi. Okay, so it had to go. So really, when you're talking the unit circle, it went all the way around 360 degrees, or 2 pi if you're talking radians, to get back to its starting point. So that's what a period is. It's where it goes until it starts repeating itself again. Okay, so let's talk a little bit about the xy axis here when we're talking periodic functions. Let's kind of close that down. And our xy axis is going to look a lot different for here. Now our y values are going to stay the same, except let's start this at 1, and then we'll make this 2. Okay, and this will make 1, -1, and this will make -2, just so we have a bigger space between 0, 1, and 2. Alright, now our x-axis is what changes. Our x-axis is going to change to radians. So it's going to be pi over 2, and then it will be pi, and then 3 pi over 2, and then 2 pi. And your standard sine wave will start out at 0, 0, go up to 1 at pi over 2, down through pi, down to -1, and up there. But one of the things that will happen when we're doing these sine waves is it will grow, it will mush together, it will stay the same shape, it'll just look a little bit different. So it might be that you get a sine wave that looks like that. So it went up higher, and it didn't take as long to go through one period as the green one. See, it took all the way 360 degrees, or 2 pi, to get to where it started repeating itself, and this one started repeating itself at pi, or 180 degrees. So it started repeating itself sooner, and then if it continued, it would do something like that. So it would go through 2 periods in 2 pi rather than 1. So we're going to look at some different things that will change that, the period, and what is called the height that it goes up, which is called the amplitude. And we'll look at how it changes in a little bit. Now right now we're just starting to get an idea of what's going on here. So let's look at how we're going to relate these radian measures and how all that kind of fits together. Okay, so you're used to looking at this unit circle. This is from page 109, and notice what happens here. Let's say that we have a point right here, and it starts traveling, and it travels around this unit circle all the way around to its starting point, which is at 360 degrees, or 2 pi. We're going to stick with radians and call it 2 pi from now on, and I'm not going to say degrees as much. Alright, so what happens is it starts going up. When it gets up to pi over 2, or a 90-degree angle right here, So the blue and the red is the degrees, and these are the points on the unit circle that we're at those at 30 degrees. We're at the square root of 3 over 2 and 1/2. Okay, so when we get to 90 degrees, or pi over 2, we are at 1 for our y value. So look what we're going to do here. We're going to go over pi over 2, 90 degrees, and we're going to go up 1. That's our y value. Alright, let's continue on. If we continue on here, when we get to pi, our y value is 0. So when we're at pi, we didn't go up or down. Let's continue around. When we get to 3 pi over 2, our y value is at negative 1. So we're 3 pi over 2, negative 1. And when we get all the way around back to 2 pi, our y value is 0. And when I draw this curve, I get a sine wave. Okay, so what I'm trying to do is get you to just understand what's happening here. This graph is another way of making this unit circle here. That's all it is. It's just another way. And as we go up here and move around, we're going up here and moving around. You can kind of look at this as this is the top half of the circle above the x-axis, and this is the bottom half of the circle under the x-axis, or under the x-axis. Now it's not going to be perfectly round, but those are the points that we're dealing with. When we're above here, these are the points here. See, it goes all the way to pi. So from 0 to pi, 0 to 180 degrees, we're above the y-axis, and then down here we're below. So you could kind of take this whole half and just set it here, and then take this half, cut it away, and set it here. And then you get those graphs. So where do we get this information here? Well, it's really easy to get the information off of this right here, but there is a formula, and the formula is y equals the sine of x. That should be familiar with you. We worked with this back in chapter 3. So all we have to do to find our y value is put our calculator in radians, and let's say we want to find the y value at sine of pi over 2, this one right here. Okay, we take our calculator in radians, put in pi over 2, and it will spit out a y value of y. If we put in our calculator pi over 6, and we take the sine of pi over 6, it will give us a y value of 1/2. So it will give me a y value then of 1/2 here. So it'll be right there. If I put in an x value right here of, let's say, pi over 4, sine of pi over 4 will give me a y value of the square root of 2 over 2. And then I can graph that here. And if I do a whole bunch of points, I get a nice smooth curve of where this goes. So the key here is to take the sine of any of these, blue here from page 109, and then it will kick out a y value, and it will always kick out this y value. So we're kind of ignoring these x's that are right here. We're not really even using them right now. We're using the blue radian measurements as our x values, because notice we have those here as our x values. We have the radian measure of the circle, or of the angles here, and then the y values, once we take the sine of that, it will give us the points going up and all the way around here like that. So if I took the sine of, let's say, 7 pi over 4, it would give me negative square root of 2 over 2. And you could take the square root of 2 in your calculator, divide it by 2, and take the negative sign, and it would give you a point somewhere in this area right here. Because this is about, well, that's 3 pi over 2, and we're talking 7 pi over 4. So that's somewhere halfway in between here. And you go down and you get your negative square root of 2 over 2 then for your y value. Okay, so you see how that corresponds. It's It's going to take some practice. It's all brand new stuff, but that's kind of how this all works, is we're just comparing this circle here with this. And so it would be good to have this somewhere close. Tape it in your book or something so page 109 there is real quick to access until you get some of this memorized. Alright, so let's go to 4.1b as in boy, the second video.